Hi guys, and welcome to this next lecture. We're going to be continuing with our parallel resistor circuits, but now getting into a little bit more of the circuit calculations. So let's have some fun with this one. Okay, so I've written a whole heap of notes here. You guys can download this as a PDF from the resources section, which I think will help. Now we're going to be looking at two different ways of figuring out how much total resistance there is. Ooh, let's do this properly. How much total resistance there is when we just have two resistors in parallel with each other. Now, you'll probably recall that if we have, say, a 1K resistor like this, and that's it in a circuit, the total resistance is simply 1K because that's all there is. But if you were to put in series with that another one that is also 1K, which way does the resistance now go? Does it go up or does it go down? Well, overall it goes up, because in series we simply add them together. 1K plus 1K is going to be 2K. Anytime you put resistors in series, you're always going to get more resistance than you had before. In this case, 2K is bigger than 1K. Now, it's the direct opposite of that when we deal with parallel circuits. In parallel, you're always going to get less total resistance than you had before. So just to quantify that, if we have a look at this, electrons go this way. Let's pretend this guy wasn't there to begin with. The only electrons you've got are the ones flowing through R1. That's it. If we were to put this one in parallel with that, we have now opened up a bit of an option for those electrons to take. They can go this way, or they can go this way. So overall, we're giving the circuit more opportunities for the current to actually flow from the negative to positive, and therefore we get more current flow. Just like with a supermarket checkout, you open up more checkouts, which is like our parallel resistors, you get more people getting through. So series, you put more resistance in series, you increase the resistance. In parallel, you decrease the resistance. But how do we calculate how much that resistance is? Well, that is a good question. In fact, we're going to do that right now. So, the first way we're going to go through is the product over sum method. Now, if you remember back to high school perhaps, you may have spoken about the product of two numbers. The product of two numbers is where you multiply them. So in this case, we're concerned with the resistors R1, R2. So we get the product of them, which is R1 multiplied by R2. When we talk about over, that just means this line here, which means divide. So we want to get the product, R1 times R2, then divide it by the sum. The sum is a fancy way of saying R1 plus R2. So here's our product. There we go, product, and we're going over, divided by the sum. That's all we're doing. It only works when you have two resistors. After we do this one, we'll talk about the reciprocal method to figure out the total resistance. A little bit harder to do, but it works with any number of resistors that you've got in parallel, which is pretty good news. So again, just to show you where we're heading, we want to know what is the total resistance there. If this power supply was to have one single resistor connected to it, kind of like we did with the series, what value would that be? What would we make that value there that would do the same thing as these two in parallel? That's what we're trying to aim to achieve here. So, product over sum. We've got R1 times R2, there's our product, divided by R1 plus R2, that's our sum. R1 is 1K, R2 is 1K. So 1K ohm times 1K ohm is 1,000,000. Let's just double check that to be sure. 1K times 1K. And I'm telling the truth. 1 and then the little 6 there, which means 1 with 6 zeros, 1,000,000. Divided by 2,000, which is the sum. 1K plus 1K gives us 2K. So now we finally do the over part of it, which is the divide. So we go 1,000,000, 1 exponential 6 to get million, divided by 2,000, which is 2 exponential 3, and we get 500. So all I'm saying here is, if we had this 10-volt power supply, and we were to get exactly the same amount of current flowing in this circuit as the total current in this circuit, what resistor would we need to put in there to get that? Well, it'd be a single 500 ohm resistor. That is one method. Let's have a look at the other method. This one is called the reciprocal method. A little bit harder to do, however, it works with 3 resistors or 4 or 5 or 10 or 100. It works with loads more resistors than just simply 2, whereas this one you can only use with 2. Now again, to get RT, which we're going to find out is 500 ohms because we're using the same values. But the way we get this is we first have to go 1 divided by, or 1 over, and then we have to do each one of these separate resistors like this, 1 over R1, and then plus 1 over R2, and then if we had a third one, plus 1 over R3, and we'd keep going for however many we've got. So 1 divided by, let's just take care of the R1 and R2 first. Let's do it in stages. 1 divided by 1K is going to give us 0.001. 1 divided by 1K, same thing, 0.001. We add those two together, we get 0.002, so we can do these things on the calculator here. 1 divided by 1K is going to be, now unfortunately the calculator sometimes gives me some annoying numbers. Let's see if I can get this to be not as annoying. There's our 0.001. It was giving it to me in engineering notation, but realistically it should have given me 1 to the negative 3, because that's how many places we've moved this decimal place, 1, 2, 3. But there's our 0.001, we just add that to the same thing. There's our 0.002, and then finally to finish off this equation we have to do 1 divided by that. Now most calculators you can do it this way. You can go 1 divided by, and if you push the shift or the second button like that, the equals key, so every time I press that it gives me another option for my equals key and for a lot of other buttons, but the equals key turns into a last. Sometimes some calculators have an ANS button, so it's got written on it ANS, or sometimes when you press the shift button the equals key becomes an ANS button. Different calculators, it means the same thing. It just means give me my last answer. My last answer was 0.002. So I'm going 1 divided by my last answer, which was 0.002. There it is. What does that now equal? 500. So just to recap that one, all I did there was I went 1 divided by 1K, and then I did that again, and I added them together. So to do that in one smooth sequence, I could go plus, and then open bracket to keep this little equation separate, 1 divided by 1K equals, there's my 0.002, and now I need to do 1 divided by that. So I go 1 divided by my last answer, second, equals, to get my last. And what does that equal? Well, it's 500. So there it is, 500 ohms. So let's just to make sure that I'm not telling you anything wrong, let's set up this circuit. So 10 volts, let's put a resistor in there, let's put another resistor in there, let's connect it up, and again this auto routing feature doesn't really like to auto route very well. Well, it automatically likes to do its own thing, it seems, because I like to have it down here like that. Okay, there's my two resistors, there's a 10 volt power supply just like we've got right here. 10 volts, 1K, 1K. How much current do we have? We have 20 milliamps, and that splits off into 10 going up that way and 10 going across that way. What if we replace that with a single 500 ohm resistor? Would we still get 20 milliamps? Yes, yes we do. So the 10 volt power supply, he doesn't care if you've got two 1K resistors in parallel. He still thinks you've got 500 ohms there because you're getting 20 milliamps. Here's a 10 volt power supply, single 500 ohm resistor, same thing, 20 milliamps. Now lastly, let's do one last calculation to see that this story checks out. 10 volts divided by, how much current have we got? 20 milliamps. 20 exponential, start again, 10 volts divided by 20 milliamps, exponential negative 3. How much does that give us in resistance? 500 ohms. So it's all working out. Very good. Let's do some more calculations right here. So we'll first start with product over sum, and then we'll move on to some reciprocal. So we want to know these two resistors, if you were to replace it with one single resistor, what would that value be? So product over sum is 3K ohms multiplied by 4.8K ohms, and then over the sum, which is 3K ohms plus 4.8K ohms. Let's pull out our calculator. So we'll do the top bit first. 3 exponential 3 for 3K multiplied by 4.8K equals that, and we're going to divide it by the stuff down the bottom. So when we do this, to do it all in one fluid motion, instead of having to write down the 144 and all that, we just put the stuff down the bottom in brackets. So divide that by all this stuff, 3 exponential 3 plus 4.8 exponential 3, which is 4.8k, and then close the bracket now that we've finished the stuff down the bottom, equals, and we're getting 1846.153846 ohms. When I'm dealing with resistance, I accidentally pressed the wrong button. Sorry, I have to do that again. 3 exponential 3 multiplied by 4.8k, and then divide it by the stuff down the bottom, put that in brackets, 3 exponential 3 plus 4.8k. Close the bracket. As I was saying, I normally round this to just whole numbers. So I'm going to leave that at 1846 ohms. 1846 ohms. So remember what I was saying before, anytime you put resistors in parallel, you're always going to get a smaller resistance. In this case, 1846 ohms is smaller than the smallest resistor, which is 3K. So even before we do this next example, we know that it's going to be less than 800 ohms. It will always be less than the smallest resistor. So let's do this, 1.2K multiplied by 800 ohms over the sum, which is 1.2K plus 800 ohms. Let's get the calculator. 1.2K multiplied by 800 ohms, what does that equal? Well, it's that. Now let's divide it by the stuff down the bottom, which we need to put in brackets. Divided by 1.2K plus 800 ohms. 480 ohms. Is 480 ohms less than 800? I think you'll find it is. So if we were to replace those two with one single resistor and still get the same amount of current, that value would be a 480 ohm resistor. Last one, then we'll move on to some other stuff. What do we got here? So RT equals 750 ohms, not plus, multiplied by 10K. So have a think about what is this going to be less than? It's going to be less than 750 ohms. Always less than the smallest resistor. 750 multiplied by 10 exponential 3 for 10K, and then divide that by 750 plus 10K. Close the bracket. We're getting 697. In fact, because that's a 0.67, I'll round that up to 698. 698 ohms. Good. Let's try that stuff again with reciprocal. Now this is a little more difficult. Reciprocal method, you've got 1 divided by, then 1 divided by R1, which is 3K, plus 1 divided by R2, which is 4.8K. So a little bit more difficult. So let's have a look at the way that I think is a pretty good way to do this. We'll first deal with doing the stuff down the bottom. We'll do 1 divided by that, then we'll do plus, and then we'll add this one, but we have to put that in brackets. Once we've done all of the stuff down the bottom, and there could be 10 resistors there, we then, once all that's done, then we finally do 1 divided by that total answer down the bottom. So follow me with this. We'll go 1 divided by 3K equals, then we do plus, have to put this one in brackets to keep it by itself, 1 divided by 4.8K. Close that bracket. So now we've added these two together. To get the final answer, we just need to do 1 divided by what we've got on the calculator screen. 1 divided by the last answer equals, there it is again, 1846 ohms. 1846 ohms. Let's try again. RT. We've got 1 divided by, and then R1, which is 1.2K, plus 1 divided by 800 ohms. So follow me with this one. We're going to do this part first, then we're going to add this part, then finally we do 1 divided by that whole thing we got down there. 1 divided by 1.2K. Now we've got that part first, then we need to add this second part. Now we need to put this second part in brackets to make sure we do it in the correct order. 1 divided by 800 ohms. Now we've got all of that down the bottom. We've got that divided by that, and then we added that to 1 divided by that, which is what we see on the screen. To finally get RT, we need to do 1 divided by what we just found down there. So 1 divided by the last answer equals 480 ohms. So it's all lining up with what we had over here. 1846, 480, and let's do this last one. RT equals 750 ohms, so we've got 1 divided by 1 on 750 plus 1 on, what do we got here, 10k. So 1 divided by 750 ohms equals, then we add the 10k, so it's open bracket 1 divided by 10k, close that bracket. We've now got all the stuff down the bottom. Now we do 1 over that answer. There's our 697, now we round it up to 698. 698 ohms. Exactly the same as what we had over here. Oops, 2 pages. Same as what we had over here. Okay, so to finish off, just being a little conscious of the time, so we'll have to get through this. I just want to work out all the values around this circuit, starting with the total resistance, and then getting all the different current values. So product over sum method, let's figure this one out. 2.2k times 3.9k ohms over the sum, which is 2.2k ohms plus 3.9k ohms. What do we get for that? 2.2k multiplied by 3.9k, and then we divide it by 2.2k plus 3.9k. Close the bracket. 1406 ohms. I'm going to round that up to 1407 ohms. So effectively, this circuit here with those two resistors is going to have exactly the same amount of current as a single resistor, that is 1407 ohms. Now, how much current will that be? Well, we know the total resistance, so let's get total current. So 12 volts total voltage divided by the total resistance, which is now 1407 ohms. The current is going to be 12 volts divided by 1407 ohms, which is, and let's have a look at that with engineering notation, 8.5 rounded up to 3 milli. 8.53, that's about 5 milliamps. But what about the current? I mean, that's the total current, 8.53. Oh, it's a bad 3. 8.53 milliamps, that's how much there is total, but how much of that goes up there, and how much of that goes up there? Well, to get the current through resistor 1, we need the voltage of resistor 1, which is 12 volts, because it's in parallel, divided by the resistance of resistor 1, which is 2.2k. And that's how we get the current through resistor 1. 12 volts divided by 2.2k, 5.45 milli. So, of that 8.53, most of it goes up the 2.2k resistor, and we'll find out that not as much as that goes up to 3.9. The 3.9 also has 12 volts because it's in parallel with the power supply. How much current do we get? Well, we do 12 volts divided by 3.9k, and we're going to get 3.08 milliamps. So we have 8.53, 5.54 goes that way, and then the rest, which is 3.08, goes that way. Let's check it on the circuit simulator to be sure. We should have 8.53 milliamps, which we do. Give that a tick. We should have 5.45 going that way, which we do. Give that a tick. And we should have 3.08 going that way, which we do. Have a tick. Well, that's it. I'm out of time. Do your quiz, and then we'll go on with the next one, which has 3 resistors. Thanks, guys.